Hello friends, I welcome you all to the course Marketing Research and Analysis. In the last lecture we covered concepts of correlation, right. So, we understood what is correlation and how it impacts or how it explains the relationship between two variables or more than two variables. Sometimes we just find out the relationship between two variables and more, and sometimes we partial out or we try to control one variable and see the effect of other variables, right, which was a case of partial correlation. Today we are trying to discuss on another important concept, a very important concept and very highly utilized in all spheres of education or academics, be it management or be it social science, be it engineering, wherever you can think of, and this is regression. So, regression basically is very interesting because this concept actually means to regress towards the mean or to move towards the mean. So, what it means? So, something that there is a law of the nature tends to average out everything, right. So, if something has happened some high, you have got some high value, that the next time when you do the same exercise, the chances are fair that you will get a low or a lesser value which is closer to the mean. So, regression means to regress or to where does it regress? Towards the mean, that is what it means, right. So, what exactly is regression? It is a very powerful and very but flexible approach or procedure for analyzing associative relationships between a metric dependent variable and one or more independent variables, right. But it has to be, it is like y and x, and both this y, let us say it could be x1, x2 up to xn for example, right. So, these are both in metric, okay. This is a metric variable and these also have to be metric, right. This is how it is defined. So, it can be used in the following ways to determine whether the independent variables, so these are my independent variables, explain a significant variation in the dependent variable. So, my dependent variable, so any change in my dependent variable will be explained by a change in the independent variable, right. So, what is the relationship? What is the how much in the how much of the variation or the variance in the dependent variable is explained through the independent variables, okay. Second, to determine how much of the variation in the dependent variable can be explained by the independent variables, first it is whether the relationship exists and second the strength, okay. The third, to predict the values of the dependent variable, you need to find out, calculate how much, what is the change in the, what is the y value, right, for a particular x1, x2 or particular x value, right. And the third and last is to control for other independent variables when evaluating the contributions of a specific variable or a set of variables. Suppose I want to find out the effect of x1 on y, I want to control x2 or I want to take x1 and x2 and I want to control maybe x3. So, we will start with a simple linear regression model, okay. So, as it says, linear regression is the next step after correlation. So, you have understood correlation, very clearly you have understood correlation. Now, it is the next step. So, it is used when we want to predict. So, this is regression analysis is also called as predictive analysis, right, predictive analysis. Sometimes you must have heard this term predictive analysis. To predict the value of a variable, value of a variable is which variable? Now, y, the dependent variable, based on the value of another variable which is the x, the independent variable. The variable we want to predict is called the dependent variable or the outcome variable. The variable which you are using to predict the x, right, is called the independent variable or the predictor variable, right. For example, you could use linear regression to understand whether exam performance can be predicted based on the revision time. So, how much time a student is using for revision as a for revising his subject, that will have an impact on how he is performing in the exam, right. Another example, whether cigarette consumption can be predicted, can we predict how many cigarettes does a person consume based on the time he is spending on smoking, right, duration of smoking and so forth. If you have two or more independent variables rather than just one, we say it is a case of a multiple regression. Since there are multiple independent variables, they are called multiple regression. Okay. Now, what are the assumptions of simple linear regression, right, or regression for example? Your two variables should be measured at the continuous level. I said that both y and x need to be measured in a continuous or metric, as a metric variable. So, it is either interval or ratio. Examples of continuous variables include, for example, revision time measured in hours, intelligence measured in IQ as a IQ score, performance measured from 0 to 100 in percentage or something, weight measured in kg, etc. Okay. Assumption 2, there needs to be a linear relationship between the two variables. That means what we are saying, the linear relationship means they are moving linearly, that means they have a proportionate, the movement, the change is, there is a equal change, there is a proportionate change. Okay. Third, there should not be any significant outliers, because if there is an outlier, it will drastically distort the entire relationship. You should have independence of observations. So, this independence of observations can be checked by a Durbin-Watson test test, which is also a measure of autocorrelation. Now, just forget this is autocorrelation. So, if you want to check it, you can check through this also whether the presence of autocorrelation is there or not, and this helps you to find out independence of observations. But just imagine and understand, independence of observations we mean that no variable or no respondent is repeated for more than one time. That means it gets a chance to be a part of the study for once only, right, until and unless we are doing a repeated measure design. So, you have understood earlier experimental design. So, in that we are saying in our factorial design and whatever we are doing. So, there we are using the independence of observation assumption. So, that means one respondent can be part of the study for once only, but if the sample is repeated for let us say 2 times. So, once for year 1 and once for year 2, then it is called a repetition of repeated measure observation. Okay. The last assumption is the data needs to be homoscedastic, right. What is homoscedastic? This is where the variances along the line of best fit remains similar. Now, look at this case, right. So, homo means similar, right. So, similar variance, that means the variance is similar, right, and if the variance is not similar, it is hetero. So, these two cases are heteroscedastic. You see the variance here and you see the variance here. So, there is a large gap, this is a significant difference, right, but look at the gap of the plots or the data points here and here, everywhere it is more or less the same. This homogeneity of variance is a very important assumption, right. Homoscedastic or the homogeneity of variance is a very important assumptions in any statistical analysis. One more thing is you need to check the residuals or errors. Now, what are these errors? Please understand them. Many a times students get confused. The errors is basically the unexplained part in a study. Now, let me explain it through maybe a diagram if possible. So, what I will do is I will draw it here. I have some space. So, let us say this is my x and y, right, this is my y, this is my x. Now, let us say I have, this is my y mean, okay. So, the value of y is the average value of y. Now, let us take a variable and we are assuming now this. Now, this is where I am saying is my y estimated. Now, what is y estimated? Means the y which you have calculated, the calculated value of y, the dependent variable that you have calculated. Now, let us take a variable here. Now, this is my y observed. So, although my estimated calculated y is this much, my mean is this much, but this is my real y or my observed y. Now, if you look at this part, this entire thing, this total from here observed minus the mean, this part is called my total variance. Okay. Now, so y is equal to y minus y bar, summation of this, right. Similarly, if you look at the y, this y bar estimated y minus the y bar, sorry, this looks like x. So, y estimated minus y mean, this gives me what? Now, this is the one which we call as the explained variance. So, explained variance, right. So, this is called sum of square of regression also, it is sometimes denoted as sum of square regression, right. What is this part? The y, the actual y minus the estimated y. Now, this part is what is called my unexplained variance, and this unexplained variance is called as sum of square of error or residual. So, when I said this residual is nothing but this part. Okay. So, you need to check that the residuals of the regression line are approximately normally distributed, they should be normally distributed, right. Two common methods to check is through a normal, so with a through a normal PP plot, right, or a histogram, or I have explained when I was talking about data purification, you can easily go and calculate and find out whether they lie within the range of -2 to +2, and if it is yes, then it is within the range, and then we say it is normally distributed. If it is beyond -2 to +2, then we say it is not normally distributed, right. Otherwise, just you can go through a histogram or a normal plot and PP plot and find out. Now, let us take this case. A salesperson for a large car brand wants to determine whether there is a relationship between an individual's income and the price they pay for a car. So, he wants to know whether there is any relationship between individual's income and price. As such, the individual's income is the independent variable and the price they pay is my dependent variable. The salesperson wants to use this information to determine which cars to offer to the potential customer. Suppose a customer is a very high income customer. So, which car should he be shown, right. So, to offer potential in new areas where average income is known to them. So, as it says, regression analysis involves one independent variable and one dependent variable, which we have understood, in which the relationship is approximated by a straight line. Now, what is this straight line? So, let me explain that point. So, for example, if you see it is something like this, right. So, we say this is the regression line, let us say, and this line is called the best fit line. Why it is called the best fit line? Because there could be infinite lines, right, there could be infinite lines, but this is the line which we are saying is the best line. Why? Because if you take all the data points, and calculate the variances, right, the distance from this line, then you will see that it is in this line that the variance is the minimum, right. If you would have taken any other line, like say this one, or let us say here or somewhere here, then the variance would be more in comparison to when you take this line as the line, regression line, right. So, we have understood that this is a case of simple linear regression, and when we are using more than two independent variables, right, two or more, then we say it is a case of multiple regression. Now, let us go to this example. Anand Pizza Parlor is a chain of food restaurants located in 5 states. The most successful locations are near college campuses. The managers believe that quarterly sales for these restaurants are related positively to the size of the student population, right. So, which is X, right. That is, restaurants near campuses with a large student population tend to generate more sales than those located near campuses with a small student population. Obviously, pizzas are more liked by students, right. So, now using regression analysis we can develop an equation showing how the dependent variable y is related to the independent variable x. So, what is y? Sales, right. What is x? My size of population, okay. So, now in the Anand's example, the population consists of all the Anand's restaurants. For every restaurant there is a value of x student population and a corresponding value of y sales. The equation describes how y is related to x and error term in the model, okay. So, you see y is equal to b0, or this is beta, right, plus beta 1 x plus e. Now, what is this? Let me explain. Where b0 or beta 0 and beta 1 are referred to as the parameters of the model, right. So, this parameter is called my intercept, right, and this is called my slope, right. So, had you had more number of x, for example, x1, x2, x3, so there would have been beta 1, beta 2, beta 3 goes on. But what is this error? I just now explained the unexplained variance or the residual or the errors. Okay. Okay. So, these are the things we have. The Greek letter epsilon is a random variable referred to as the error term, this one. Okay. The error terms accounts for the variability in y that cannot be explained by the relationship between x and y. Okay. So, let us understand again, let us draw a line. So, this is my, let us say this is the regression line. Now, this is called my intercept, the one which you are seeing here beta 0, and this is my beta 1, right, the slope. So, y is the beta 1 x which we are talking about. So, this is the beta 1, so the slope, right. Now, continuing, the population of all Anand's restaurants can be viewed as a collection of subpopulations, one for each distinct value of x, right. So, x was my size of the population. For example, one subpopulation consists of all the restaurants of Anand located near college campuses with 8,000 students and so on. Each subpopulation has a corresponding distribution of y values. So, for each value of x there will be a corresponding value of y, obviously, right. If x is 8,000, the y is something is let us say y1, if it is 7,000, let us say y2, it is 9,000, let us say y3. So, we have corresponding values. Okay. Thus, a distribution of these y values, this distribution of these y values y1, y2, y3, y goes on, right, yn is associated with the restaurants located near the campuses. So, each distribution of y values has its own mean or expected value. That is what I was trying to say in the when I started the lecture, that regression is regressing towards the mean, right. So, what is the mean or the expected value? The equation that describes how the expected value of y is related to x is called the regression equation. So, the regression equation is Ey is equal to beta 0 plus beta 1 x, that means my intercept plus my slope into the independent variable. Now, these are some of the relationships you see in correlation also you have seen this. So, if you see, if I take a slope between x and y, so this part is my intercept as I have shown beta 0, right, and this is my regression line, these are the regression lines, right. So, in this case you see, in this case the beta is positive, the beta 1 is positive. So, when it is positive, we say it is a positive linear relationship, that means as x is increasing y is also increasing. But in this case, as x is increasing, you see the value of y is decreasing. So, the slope is negative in this case, it is a negative linear relationship. The third case you see, with the change in x there is no change in the y. So, the slope is 0, okay. So, there is no relationship, right. If the values of the population parameters beta 0 and beta 1, the intercept and the slope were known, we could use previous equation to compute the value of y for a given value of x, obviously. So, if I need to find the value of y, the calculated the estimated y, sorry, estimated value of the dependent variable, and I know my x, but I do not know these two, I need to calculate, right. So, in practice the parameter values are not known and must be estimated using the sample data. Since you cannot infer it from the population, it is difficult. So, you have the sample. So, let us use the sample, and because it represents the population, and calculate the beta 0 and beta 1, the slope, right. So, sample statistics B0 and B1 are a reflection of the same beta 0 for the population, right. So, are computed as estimates of the beta 0 and beta 1, right. Substituting the values of the sample statistics beta 0 and beta 1 for 0, so that means the intercept is 0. So, if intercept is 0, that means it is starting from the origin, and 1 in the regression equation, we obtain the estimated regression equation. So, this is how it looks like, okay. Now, this least square method. So, least squares is a procedure for using sample data to find the estimated regression equation, right. So, in the case of this Anand's case, there are 10 restaurants, student population in thousands is given 2,000, 6,000, 8,000, 8,000, 12,000 up to 26,000. The sales is given to us, right. So, now it says 10 Anand's pizza restaurants are the data is given, right, and the xi is the size of the student population in thousands, yi is the quarterly sales in thousands of dollars. So, the values of xi and yi for the 10 restaurants are given to us, right. Now, if I draw the data points, right. If I draw the data points, this is what it says. The student population is shown on the horizontal axis, okay, and quarterly sales is shown in the y axis. So, scatter diagram is just a representation of the data points, right. Further regression analysis are constructed with the independent variable x and y, right. The scatter diagram enables us to observe the data graphically and to draw preliminary conclusions. You can't draw any final conclusion, but preliminary conclusions about the possible relationship. Now, just see this and tell me what is the relationship you think. So, this is a positive relationship, it is growing, as x is growing, y is growing, right. So, this is a positive, if this is my regression line, so this is a positive relationship. Okay. From this figure we can find out that. Now, quarterly sales appear to be higher at campuses with large student populations. In addition, for this data, the relationship between the size of the student population and quarterly sales appears to be approximated by a straight line, indeed a positive relationship, right. We therefore chose the simple linear regression model to represent the relationship between quarterly sales and student population. Given the choice, our next task is to use the sample data and determine the value of B0 and B1, the sample parameters, right, in the estimated equation. If we find out this, suppose B0 and B1, then for any x1 we can find the value of y, right. So, y is my estimated value of quarterly sales, B0 the y intercept, B1 the slope, and x1 is the student population size. Okay. So, the criteria is saying, why this is what I was explaining, the minimum, the criteria, least square criteria is the yi summation of yi minus y bar square, right. So, I had explained you, so least square what it says, the minimum, minimize this, what is this minimize, just go back, let us go back to the diagram. So, I said earlier this was my estimated y, this is my y bar, and we have a observed value y, right. So, let us I think it is not visible. So, y. So, this part was my unexplained part. So, the intention of the researcher is always to minimize this part and to reduce it as much as possible. So, that means what, our estimated value should be able to incorporate or accommodate the actual observed values. Okay. So, y is my observed value of the dependent variable for the ith observation, and y I is my estimated value. So, if my observed value minus my estimated value is 0 is equal to 0, that means what, observed value is equal to estimated value, that means what, we can say that it lies on the same point, which means that there is no unexplained variance, everything is explained in the study. Okay. It is a very important concept, because the more unexplained you have, that means the researcher has very little control over the research. Okay. So, how do you calculate this slope, right, and intercept? So, first let us calculate the slope. So, the formula is, if you see, B1 is equal to summation of x I minus x bar, right, each observed value minus the mean, right, summation into yi minus y bar, right, and divided by the summation of xi minus x bar square, right. So, this is the xi is my value for the independent variable for ith observation, yi is the value for the dependent variable for the ith observation, sorry, x bar is the mean value for the independent variable, y bar is the mean value for the dependent variable, n is my total number of observations. Okay. So, once we get this, right, and I have, let us say the y and x, the estimated, right, the mean and the mean value of y we have, the x value, then we can calculate B0. So, let us do this, So, first we find out that these are the 10. So, this is my xi, the values which earlier also we had shown, and this is my y, right. Now, first we will calculate the x bar. So, x bar is how much, 140 divided by 10, so that is equal to 14. Y bar is how much, 1300 divided by 10, 130. Okay. We need x minus x bar. So, we find out x minus 14. So, 2 minus 14, 6 minus 14, 8 minus 14, 8 minus 14, 12 minus 14 goes on till 26 minus 14, right. So, x minus x bar. Similarly, y minus y bar, 58 minus 130, 105 minus 130 and goes on till 202 minus 130. So, y minus. Now, we want x minus x bar into y minus y bar. So, we can do this, calculate this, multiply, and we have found out this. Okay. Now, x minus x bar square is what we are finding out. So, x minus x bar square 12 square 144, 8 square 64 goes on, right. So, after finding everything, see this is the formula. So, we have got everything now with us. So, let us use the formula. So, this part x minus x bar into y minus y bar, right. This is how much 2840 divided by 568. So, my slope is equal to 5. Okay. Now, we will calculate the intercept. So, to calculate the intercept B0, we have y bar is my mean. So, 1300, so 130, okay, minus 5 the slope into x bar the mean, right. So, mean is 14 here, right. So, 14, okay. So, this gives me a value of the intercept is 60. What does intercept mean? It means that whenever you do not have any value for x, that means when x is 0, still there is some value for y, and this value for y is nothing but the intercept. The meaning of this is that when x is equal to 0, whatever value of y remains, that is my intercept, or that is my intercept. Okay. So, the estimated regression equation is now y estimated is equal to 60, this is my slope, plus 5 the slope, right. So, this looks like how do you look now, B0 plus B1 x, right. So, B1 is my 5 into x, right. So, for any new variable, any new value of x, now you can calculate the value of y, you can estimate, right. So, for example, in this case, so let us say B1 is positive, implying that as student population increases, sales increase, because the slope is increasing. In fact, we can conclude that an increase in the student population of 1000 is associated with an increase of 5000 in expected sales, that is quarterly sales are expected to grow by $5 per student, right. If we believe the least square estimated regression adequately describes the relationship between x and y, it would seem reasonable to use the estimated regression equation to predict the value of y for a given value of x. So, example, if we wanted to predict the quarterly sales for a restaurant to be located near a campus with 16,000 students, we would compute as how? Now, y is equal to estimated y is equal to 60, which is my intercept, plus 5 is my slope, into 1000, we are taking it only the numerics, the 16. So, 16,000, because that is how we have written. So, finally, this becomes 140,000, the sales is 140,000. So, this is what we understand, right. So, this is how graphically this is how it is shown, this is the regression equation. So, this is my slope and this is my intercept, everything is shown here. Okay. Now, I will show you how to just do it in the SPSS. First, let me show you on the slide also. So, how do you do it in regression? Go to analyze regression, go to the linear model, and then you take what you want as a dependent, you take it here, and what you want to take the independent, you take it here, right. So, here price and income, this is just an arbitrary example, right. So, we have taken, right, and then we need to check. Okay. So, let me show this and the model summary, obviously this is later on will come. So, but if you want to understand, just understand, you will get such kind of a descriptive table, a model summary, which this is the R, right, and if you remember this R, we had said this is related to the multiple correlation value, right. So, anyway, now let us go to this, what is this at R square, what is the adjusted R square, I explain. R square is nothing but the square of this value, and adjusted R square is something very interesting, which will later I will explain, that adjusted R square is a value which goes on increasing up to a particular level as you increase the number of variables, but then after a certain point of time, when you add more variables, the adjusted R square value actually starts declining, right. So, that means there is either no change or it starts declining, because the point is the adjusted R square only accommodates those variables which contribute to the data or to the dependent variable, right, or to the study, right. Okay. So, let us go to this, we have a simple regression. So, simple regression. So, I go to analyze. So, this case is IQ and grade. So, is grade affected by IQ? So, let us see. So, I take grade as my dependent variable and IQ as my independent variable, right. So, this is a very basic regression we are doing and we are understanding, right. So, you can go to statistics and you can see there are several things I want to check descriptives, for example, R square change is not required here. So, for example, independence observations you can check it through the Durbin Watson, which is an autocorrelation again. Collinearity, I will explain it later on, what is the role of collinearity, what is multiple collinearity, multi-collinearity problem, I will explain later on, but forget it for the moment, right. So, you want to anything else? No, I do not want to do any change here. So, I just want to run it. So, I see, you see, if you look at this now, first what is saying, the grade, the mean is 30.67 and standard deviation 9.2, IQ 49.5, 12.9, right. Now, let us look at the correlation. What is the correlation between grade and IQ? It is 0.498, and is it significant? Yes, it is significant at a 0.007 level, right. Now, look at this, yeah, then the model summary. So, my R, can you go up and see? So, here you had got a correlation of 0.98 and here the R is 0.98. So, that is what I was trying to explain. Many a times students do get confused, how is this R connected, is this R connected with the correlation or not. So, well, this is the output, this is same as the correlation, multiple correlation coefficient or the correlation coefficient, okay. So, R is 0.498 in this case, and thus the R square, now R square is nothing but my coefficient of determination. So, and if I divide this 1 minus coefficient of determination, I will get something which can be explained as the strength of the test. So, 0.248, but look at this adjusted R square, that means what, when I am taking all variables, it is 0.248, and remember the R value will go on increasing, right. The R square value and the R value will go on increasing as you add more and more number of variables, but the adjusted R square will not, it will remain same or it will not increase, right. So, then we say, well, this is how the model looks like. Now, this is the ANOVA, or the ANOVA means analysis of variance. So, I will explain you maybe later on. We have this is highly, these two terms ANOVA and regression, they are very strongly correlated also. You can understand from each other through from one from the other, right. And now, what is the coefficient? Now, there is two coefficients you can see, unstandardized beta coefficient and standardized beta coefficient. Now, and this is the t value and this is my significance. If you look at this IQ, so IQ, the unstandardized coefficient is 0.358, the standardized coefficient is 0.498, which you have already got, standardized coefficient is my correlation, and my t value is 2.694 and it is significant. So, that means what, we can say that IQ plays a significant role in the grade of a student. So, if the higher the IQ, because it is a positive relationship, the higher is the student's grade, right. So, this is what it explains this this is a simple linear regression model, and it has explained you how to find out the value of a dependent variable by changing the value of the independent variable. And I have explained to you what error terms mean, and you should not be afraid of the word error. It is not actually an error, it is an unexplained variance, right. So, what is the relationship between explained and unexplained? I have explained all. So, I think this is just a beginning for the regression class. We will be doing more forms of regression. Regression can be used in multiple ways. So, as I said, it starts with the basic that both the dependent and the independent variable have to be metric in nature, but we will see several special cases where it might not be, the independent variable might be in some other format, maybe in a categorical scale, but we can still do it, right. So, how we will do it and all we will see later on in the future classes, in the upcoming classes. For today, we will close it here. Thank you very much.